Hello everyone and welcome back to another problem of the day, and today's problem is titled LCP. In this problem you are given an array of n strings and your task is to find the longest common prefix among all the strings present in the array. So for the given example where n is equal to 4, that is the array length size, you are given the strings geeks for geeks, geeks, geek and geezer, and among these strings only the string or the substring GEE, which is the prefix common for all the substring, is the resultant answer. And for the second example, where n equals to 3, we have three strings apple, ape, and April, and the common prefix among them is AP. So, in order to solve this problem, let's take in the first example itself. Alright, so this is our first example. Its size is its size is 4. Now our task is to find the prefix, right? So one thing that we can do is we can sort this particular array. Why sort? Because by sorting, I'll get the smallest string at the beginning of my array, and using that smallest string, I'll be able to reduce my comparisons. Because let's say if I took in this particular string and I start comparing the beginning characters for every other string, then I might not know when to stop because there might be a smaller string somewhere within the array, and I would have to handle that accordingly. In order to avoid that, I'll simply sort this array. So after sorting, I'll get geek as first. Then it would be geeks, since K comes before Z. Then it would be geeks for geeks, and then it would be geezer. All right. Now after sorting, what I can do is I can simply make a check and compare the characters, first characters of every string in the area, in the given array, and I can simply keep a count of those characters. Let's say I keep a count. So initially it's 1, then I'll make a check for the next character, which is E. So it's same for all the other characters. So I'll increment my count again. I'll make the same check. I'll increment my count again. Now coming to the fourth character, here it's K. It is same for the first three strings, but it is different for the last string, meaning all the strings given in the for the given array don't have the common prefix as geeks. So the answer would be nothing but three characters, which corresponds to the string GEE. And using this, we'll be able to solve the problem. But if you look closely, since we have sorted the array, we need not check for every other character for every string for the given array. We simply can check for the first character and the last character. This is because since we have sorted the array, we can be assured that if for example if there were no character starting with G, if we had, let's say if we had a character called uh, what comes after G, let's say horse, then this horse, after sorting this array, this horse would come at the last. And since it comes at the last, if we keep a check on first and the last string and keep checking their characters, we can simply find the prefix. Because since we are sorting it, we can ensure that if any different character appears, it will be out of order and not in the same order. So since we have H over here, it will come at the last because H is lexicographically greater than G. That's why it will appear at the last. If we had, say, some other character starting with G, but the second character was greater than E, then let's say character greater than E would be F. So we have G, F, H, K, something like that. And if we sort these three and this character, this string, then this would appear at the last because we have sorted that, and F is lexicographically greater than E, it would appear at the last. This simply means that we only have to make a check for the first and the last character for the given array. And after making this check, we simply have to like make a check for all the other characters and make note of the count of the similar characters. And then we simply can use that count to find the substring for the uh, starting uh, string of the sorted array. And using that, we'll be able to solve our problem. So in order to begin with, first of all, as discussed, we'll be sorting our array. It would be array plus n, where n is the size of the array. Now we'll take in the first and the last character. So the first character is nothing but, let's call it f. It is array of 0 after sorting. And the last character will be L, which is nothing but array of n minus 1. Now after sorting, the loop over our array till the array of first, that is the first character size, f dot size, and not size, let's call it length. And we'll make a check for the individual characters of our considered string, that is f and l. So if f of I is equal to L of I, then we'll simply make a count, or else we can, yeah, we'll simply make a count. So in count equals to 0, count plus plus, and if that is not the case, if they are unequal at any point, then we'll be breaking out of the loop. Now we can make a check, since there could be a case where the first character itself, let's say for horse and geek, the first character itself is not same, meaning there's no common prefix. So in that case, my count would be 0, and if it is 0, I'll simply be returning -1. And if that is not the case, then I'll return the substring of first character beginning from 0 and moving till count. Let's try and compile. All right, let's try and submit. Okay, so that was it for today's video. And before concluding, the time complexity of this, as asked in the problem, it's n log n, because we are sorting the array and we are performing one single loop. And space complexity itself is O of 1 here in our case, because we are using a count variable, and using that we are taking out the substring. So our space complexity is O of 1 itself. So that was it for today's video. If you have any doubts or suggestions, you can ask them in the comment section. And thank you for watching.